Assalamu alaikum guys, welcome. Okay, so in this lecture we are going to talk about bond length and bond energy. Alright, so what do we mean by bond length in terms of a covalent bond? So bond length is actually the distance between what? Distance between two nuclei which are bonded together. Okay, for instance, two atoms which are bonded together, hydrogen atom is bonded to each other, so the distance between their nuclei is the bond length. Okay, so the internuclear distance is called the bond length. I've written it down that the distance between the nuclei of the two covalently bonded atoms is called the bond length. And what does the bond length actually depend upon? The atomic radius, right? The bigger the atomic radius, the longer the bond. The smaller the atomic radius, the smaller the bond. And now guys, remember that the longer the bond, the weaker it is, and the shorter the bond, the stronger it is. That's why the single covalent bonds are longer, okay, and they are weaker as compared to the double covalent bonds, which are stronger than the single covalent bonds. Okay, so the shorter the bonds are usually stronger. And then the reason for this is because remember guys, orbital overlap results in bond formation. When bonds are short, the overlap between orbitals is stronger. Okay, and I should rather say the attraction between the bonded electrons, these bonded electrons, and the nuclei is going to be stronger. Nuclei are positive and bonded electrons are negative, so there is an attraction between them, right, between the oppositely charged nuclei and electrons. So if this attraction is strong, meaning the stronger the attraction, the stronger the bond. So, and this attraction becomes stronger when the bond length becomes smaller. Okay, so this is a point that I would want you guys to take from here, is that the longer the bond, the weaker it is, the shorter the bond, the stronger it is. So it's in terms of single and double covalent bonds. Now coming to bond energy. What is bond energy? The definition of bond energy has been asked on the past papers as well, and this is very important. So what is the definition of bond energy? If I were to ask someone, someone might have answered you that bond energy is actually the energy needed to break a bond. Well, that is correct, but that's partially correct. That's not the complete definition. The complete definition for 2 marks is that the energy which is required to break 1 mole of a bond in the gaseous molecules or in the gaseous state. So 1 mole of a gaseous bond, the energy needed to break 1 mole, this is the first key term, of a gaseous bond or of a molecule which is in the gaseous state, meaning the energy that you need to break down the covalent bonds in a gaseous sample of molecule, and that molecule should have an amount of 1 mole. Alright, this is the complete definition, and this is what you will need to write down on your exam if you are asked to define bond energy for 2 marks. Then coming to the bond length, how does the bond energy depend upon the bond length? So basically, as I told you over here, that the longer the bond, the weaker it is, and the shorter the bond, the stronger it is. So I can say that the longer the bond, the lesser the bond energy, and the shorter the bond, the greater the bond energy. And the reason was already explained, that the internuclear distance, it becomes smaller whenever it becomes smaller. So the distance, the attraction between the bonded nuclei and the bonded electrons, it becomes stronger. Okay, now bond length usually results in decreased bond energy, and now over here I have explained these as well, that single bonds are the weakest, double bonds are stronger, and triple bonds are the strongest. That's why even a very common question comes on the past papers, that nitrogen triple bond regarding this molecule. Why is nitrogen gas inert? Why is it unreactive? Why? This is a very common question which is asked on the past papers for at least 2 marks, both in your AS as well as in the A2 and in your O levels. Sometimes it has been asked in the O levels as well. So why is that so? So basically, nitrogen is inert, first of all, because it's non-polar. Okay, it's non-polar because it doesn't have any poles, right? It's the same identical molecule, no difference in electron densities. Secondly, because this nitrogen bond contains a triple bond. It has a triple bond, this means it has 1 sigma and 2 pi bonds, so it's going to be strong. Secondly, the bond length is very short and the bond energy is very high, and this bond energy which is needed to break the nitrogen triple bond, the activation energy basically that is needed to break the nitrogen triple bond is going to be very high because of the nitrogen triple bond, which is very strong, and it is very strong because of its shorter bond length and higher bond energy. Okay, this is a very common question. So what are you supposed to write? That the nitrogen molecule has a very strong triple bond, and the activation energy needed to break this triple bond is very high. Needed to break the bond is very high. And you can also mention an additional point that it is non-polar in nature. Non-polar bonds are generally stronger than the polar ones. Then coming to this pattern over here, the halogenic acids. Basically, we will be talking about halogenic acids in a lot more detail when we'll be doing the group 7 chemistry. But over here, group 17 basically chemistry. Now over here, I'll just explain the trend. HF has the strongest bond. It is the weakest acid, whereas HI has the weakest bond and it is the strongest acid. Before I tell you why it's the strongest and why it's the weakest acid, I'll have to explain what acid is. Acid is basically any species that can donate a proton. Okay, this is the Bronsted-Lowry definition of an acid, but we'll be talking about that in detail in inorganic chemistry. That anything that can donate a proton means a hydrogen, is called an acid. Okay, now over here, since as we go down the group, the bond length is increasing. What is happening to the bond length? It is increasing. The reason why it is increasing is because the radii are increasing. Remember the group trend, that as we go down the group, the periods increase, and as the periods increase, the radius increases in size, the atomic radius. So therefore the bond length increases. So the longer the bond, the weaker it is. This is going to be the weakest bond with the least bond energy, and therefore it's going to be easiest for the HI to lose its proton. Therefore it's going to be the strongest acid. Simple. This is a very common question as well on the past year papers, to describe and explain the trend. Okay, well, up to the knowledge that I have delivered so far in the previous lectures, what sort of question that I can ask you on the basis of those lectures is that describe and explain the trend in the bond energy as we go from HF to HI. So first of all, it decreases. Reason? Because the bond length is increasing. Bond length is increasing, the internuclear distance is increasing, so the attraction or orbital overlap is decreasing. And if the orbital overlap is decreasing, then the bond energy which is needed to break the bond is going to also decrease, and therefore it's going to be a weaker bond. Simple as that. As we go down the group, it's going to become weaker and weaker and easier to break. And that's it. That's it for this lecture. See you in the next lecture then. Thank you.